All right, welcome to your review video for the Cumulative Review 1 for second semester. We're going to go through this packet, and I'm going to go through some of them. I'll just give the answers. Some of them I'll talk through a little bit more. Use this as a way to check your work and really make sure that you understand the material. Don't just view this as something you need to get done and check off your list, because this is the best thing you can do to study for your exam coming up. All right, so it says state the degree, the number of terms, and the leading coefficient of each polynomial. So thinking about what each one of those things mean, the degree is going to be the value of the highest exponent on the variable, or if you have multiple variables, you're going to add those exponents together to get the degree of the polynomial. So looking at this, I've got a 4, a 2, a 1, and a 0, so 4 is going to be my highest. Looking at this one, I've got a 1, a 4, an 8, a 3, and a 0, so 8 is going to be my highest. Here I've got a total of 13, a total of 12, another total of 12, 1, 1, and 0, so 13 is going to win out, and that's how I'm going to find the degree. The next thing then is the number of terms. If you remember, a term is separated by addition or subtraction with the polynomial. So it looks like I have 1, 2, 3, 4 terms here. I have 1, 2, 3, 4, 5 terms here. And I have 1, 2, 3, 4, 5, 6 terms there. And then the last bit of our vocab is this leading coefficient. Remember, the leading coefficient is not what is listed first, okay? It's what's listed first if your polynomial is in standard form, but your polynomial won't always be in standard form. So instead, you can think about it as the coefficient, the number being multiplied, with the variable that has the highest degree. So we already said that this one had our highest degree, which means my leading coefficient is -1. This one was our highest degree with the 8, so -2. And this one, the highest degree was 13, and the coefficient in front is 3. So again, degree, number of terms, and leading coefficient. Make sure you know each of those vocab phrases. All right, 4 through 6 says perform the simplify the expression. That's not right. Should just say simplify the expression. Oh, now I just erased part of it. Should say simplify the expression and write in standard form. Okay, a little bit of a typo on your packet. I apologize. All right, so starting here, I'm going to think about, these are brackets. I didn't quite copy very well. So order of operations would say start at the inside and work your way out. So can I combine 6x squared plus 2? Nope. So the next thing then working my way out is this negative sign. So the negative sign is going to distribute to both of these. So 3x minus 2x minus 6x squared minus 2. Then I want to say, can I combine anything in this set of brackets or parentheses, grouping symbols? No, I cannot. So the next thing is to distribute this negative sign. 2 negatives make that positive. 2 negatives make that positive. The last thing then is to combine like terms. So 3x minus 2x is just x plus 6x squared plus 2. But this says to write in standard form. Well, the standard form of a polynomial would take the highest degree, which is 2, and then write the degrees in remaining descending order. All right, this next one has a lot of i's involved. So it looks like our purpose here is going to be to simplify all these square roots of negatives. So I'm going to go through, I'm going to do each piece kind of step by step, okay? There might be some steps that you can do more combined together. There might be ones that you need to separate out more. This is just how I'm going to talk through the problem. If you do it a different way and we get to the same numerical value in standard form, then I'm okay with it. So I'm going to start by saying, okay, I to the 4th. Well, let's see, I know I, -1, negative I, 1. Apparently, I should turn on my virus protection. All right. I, -1, negative I, 1. And so this is I to the 4th. So to the 1st, the 2nd, to the 3rd, to the 4th. So this is really just 1. -2 times 1 plus, now I've got a square root of a -8, so that I is going to jump out, and I still have the square root of 8. You might be thinking, you can do more with that, Ms. Schwartz, and you're right, but I'm just going to leave it like that for now. Then I'm going to add this 5 right here, minus, another negative underneath a radical, so that means the I can pop out, and I have the square root of 50. Okay, so still cleaning up this line, I get -2 plus I root 8 plus 5 minus I root 50. So I've done some simplification, but it's not quite as simple as it could be. So the square root of 8 breaks down into the square root of 4 and the square root of 2. So this negative 2 is still here. This I is still here. The square root of 4 jumps out, and 2 is left over, plus 5, minus, the I is still there. 50 breaks down into 25 and 2. So the 5 will jump out, and the square root of 2 is still there. So now standard form for an imaginary number, for a complex number, is going to be a plus bi. So I need all my real parts, which is negative 2 and 5, which combine to make 3. And all my imaginary parts, these are actually like terms. They both have radicals with 2, and they both have i's. So I have 2 of these, and I have minus 5 of these. So that's going to be minus 3i root 2. They're kind of unusual like terms, but they are like terms. And notice this is in real plus imaginary. All right, this next one has imaginary numbers, and we're trying to get to standard form, which again would be a plus bi. So the best way to go about doing this would be to combine your fractions. And just like with fractions in the real number plane, in order to combine fractions, you must find a common denominator. So common denominator, I'm going to multiply this side by 1 minus I, and this side 1 plus I. Now what's also convenient here is that we end up multiplying by the conjugate of 1 plus I and the conjugate of 1 minus I. And that's going to be helpful because now we have created a difference of squares. That concept of a conjugate, right? X plus y multiplied with its conjugate will create a difference of perfect squares. So that's going to be helpful. So in the top, I got 2 and I got minus 2i. In the bottom, 1 times 1 is 1. I get positive I minus I. Those are going to cancel, just like they should with the difference of squares. And then I get minus I squared. Then in this one, I'm going to get 3 times 1, which is 3. And then I'm going to get 3 times I, but I had a negative sign. So it's going to be, I can make this positive, make this negative, minus 3i. If that was confusing to you, you can just leave the negative here. But then you got to keep parentheses around your 3 plus 3i and distribute the negative later. This then on the bottom is going to multiply to this same denominator, which was my goal all along. Now I can do some cleanup work. So the denominator, I can say this is 1 minus I squared. If I go back to this, this would be, oh, well, I tried to go back to that. I to the first, I to the second, I to the third, I to the fourth. I squared is going to be negative 1. So this really says on the bottom 1 minus negative 1. And this one would say the same thing. In the top then, I still just have 2 minus 2i, negative 3 minus 3i. So now these have common denominators of 2. So I know my fraction is going to end up over 2. Real part, imaginary part, imaginary part. But standard form should be in a plus bi. So I'm going to split this into negative 1/2 minus 5i over 2. If you're still struggling with information with I, that was at the end of Unit 7. So Section 7.8 was everything dealing with complex numbers and thinking about that I clock, so to speak, to go around. All right, complete the statement. All of this has to do with the discriminant. So real quick, let's remember that the discriminant is the part that is underneath the square root in the quadratic formula. And that lets us know, is my radical coming out positive, negative, which would imply imaginary, or 0, which would imply 1 real root. So if the discriminant is a negative number, then there are 0 real solutions, because you'd be taking the square root of a negative number, which results in I, which means that your solution is complex. It's not real. So the other way you could say that is there are 2 complex solutions, or imaginary solutions, if you will. Okay, apparently I cannot spell today. Imaginary solutions. Remember, every quadratic should have 2 answers because of that second degree. It's just that in this case, they come out as non-real answers. So what that looks like on a graph is your parabola is sitting entirely above the x-axis, or entirely below the x-axis because it's not going to cross the real number line of 0. If the discriminant is 5, then there are exactly 2 real solutions, which means your parabola is crossing twice, or maybe it's crossing twice, but either way, you're going to cross through that real axis of 0 2 times. And then if the discriminant is 0, then there is exactly 1 real solution. And we call that a double root because remember, I just said that a quadratic has to have 2 answers. So the quadratic having 2 answers, where you only touch the x-axis once, looks like this because you're going to touch and you're going to bounce back. Or maybe it looks like this, where you touch and bounce back, and that's what we call a double root. Those roots, finding either the real ones or the imaginary ones, or maybe that double root where you touch and bounce back. So it says for number 8 through 12 rather, solve the quadratic using any method, then write the method you chose for the problem in the space provided. So the thing is, these ones you can do a lot of different ways. You could complete the square, you could use the quadratic formula, you could take square roots sometimes if you don't have that linear term, or you could do factoring. And remember, factoring would be greatest common factor, what you guys consider traditional factoring, or splitting the middle. So what's going to happen for numbers 8 through 12 is I'm going to post the answers, and you can check those first. Then I'm going to go back and I'm going to show my work. So you can decide how much you need to watch or listen or skip, right? If you get the right answers, then you don't have to go back and listen about my work. We can move on to number 14. Okay, so go ahead and pause your video and genuinely try numbers 8 through 13 before you come back to check your answers. Really, pause it. 8, we get 0 and 9 halves. Also, this should say 13. Typos, I tell ya. For number 9, we should get x equals 4 and x equals 2. We should get x equals negative 3 halves and x equals negative 4 thirds. X equals negative 1 plus or minus the square root of 2. Make sure you're simplifying all of your square roots and radicals the most that you can. X equals 1/2 plus or minus the square root of 3. And then x equals 9/7 and x equals negative 1/7. So something to note, none of my answers came out imaginary because none of my discriminants were negative numbers, but that's okay. If you got all of these correct, you don't need to watch the video about numbers 8 through 13. If you missed even one of these problems, you should go and watch that video, skip to the problem that you need to, and watch it. Okay, now that's for my class. I don't know about Mrs. Logus, but the work is there if you need it. If you got the correct answers, that means whatever method you picked led you down the correct path, so you're good. You don't need to watch the videos about it. But be truthful with yourself. If you missed any of them, even if you were off by a negative sign or you missed one little thing, watch the next video and make sure that you really have a good understanding of this process before you go and take your test. Okay? Again, here's your answers. I'll go back so you can see them. Okay? Be honest with yourself. Watch the explanations of 8 through 13 if you need them.